moving in this direction also, we are moving in this particular direction. We will consider the C as our point. What is going to happen if you try to these are nothing but these are the two magnets which consist of north and south pole, and you people are well aware that when two opposite poles come near to each other, they are attracted, and when two similar poles come near to each other, they are reflected, they are repelled. Okay, so here we are having the two parts, two magnets which consist of two poles. One is north south and another one is also north and south. If you try to observe over here, when there is a no magnetic field, they are in the slanting manner, or in this particular manner they are specified. Now, what happens here? We people are trying to apply a force or exert a force. So, due to the force, what is going to happen? This part is that will try to elongate depending upon the force that has been applied. And when we are applying a maximum force, F, when we are applying a maximum force of the saturation, this S represents the saturation. At that time, you are going to get the maximum length that has been generated by these two poles exerted by the spring. So, in forward direction, actually, here, what is the quantity of force that has been applied, or in this particular aspect, you were applying the force. Now, in this particular aspect, in opposite mean, starting from B to A, actually, depending upon the magnetic field, inverse. So this part, if you are applying it in a mechanical manner, you are to reach the saturation level. In this particular aspect, you people can consider the mean in the mechanical to magnetic one. Only the thing you have to remember, as you are applying a force, and depending upon the property of magnetostrictive transducer, your length has been changed. Just look on the change in the length. So whether the length has been changed or not, that we people are interested to see. So over here, if you try to observe, the length has been changed compared to this particular. The length has been changed. Means it is fulfilling the requirement. So this is nothing but the one of the case study, and its thorough part I will elaborate. You just remember, I am not going to come back to each and every point. Just remember this particular C is nothing but your normal condition when there is no magnetic field, and in forward direction it is moving in the forward direction, and this is moving in the reverse direction. Now I will explain theoretical aspect that has been elaborated for your reference. So the description has been provided over here. So amount of strain produced from the null, actually figure C was the null magnetization, means to the null magnetization. From null magnetization to the null magnetization means no output, no either mechanical nor magnetizing field. It is in the null condition, zero output I will consider. So H is equal to 0, magnetic flux is equal to 0. Now again, this device, it is bifurcated into discrete mechanical and magnetic attributes. As we are having 2 points, in that 2 particular points, it has been divided into mechanical and magnetic parts, and that has been coupled in their effect on the magnetostrictive core, that is strain and magnetic induction. So first case is that where no magnetic field is applied to the material, and that one is shown in figure C. Now the change in the length that will take place, when we are going to apply a magnetic field. but at the initial condition, it is showing a null output or a zero output along a magnetic induction rule. So the amount of magnetic field H, if you try to increase that H to its saturation level, so either you can go in the forward direction or either you can go in the backward direction. In forward direction, you are getting positive magnetic field in saturation, in backward direction, negative. So this will lead in increase in the axial strain to maximum saturation voltage. ESAT is nothing but the maximum saturation voltage. So there will be increase in the value of magnetization to the value of desaturation. Okay, so figure E or decrease to figure minus B. So left hand side or right hand side, that is A. So the maximum strain saturation and magnetic induction is obtained at the point where the magnetic field H is a maximum one. It is maximum one. And on this particular point, if you even try to apply or try to increase the magnetic field, then and then also there will be no effect, because it has already reached the saturation level. So when it reaches to the saturation level and again you are increasing the magnetic field for the increase of the length, it is not possible to increase the length when it will reach its saturation level. Okay, so we will consider the other instant where your value Hs is kept constant. If saturation level is kept constant during that particular time, if we try to increase the amount of force, now in reverse manner, that is mechanical to magnetic one. If you try to apply force on the magnetostrictive material, the comprehensive stress in the material will be increased. That will increase on the opposite side, on the opposite side, because we are measuring the output in that particular instant only, along with the reduction in the value of axial strain and axial magnetization. So if you try to recall the figure C is the null one. So no flux present, so due to the no magnetization. If you try to observe figure B and D, they are having only change of the sign. One is consist of positive sign, another consists of negative sign. So in figure B and D, as the magnetic flux lines is a much lesser magnitude, so the magnetic flux generated is of less magnitude, but according to the alignment of the magnetic domain in the magnetostrictive drive, means it is showing some of the lift or some of the change in the length. Now if you try to recall a figure A, this is also having a flux line in the same design. However, the flow will be in the opposite direction of figure F. So A and figure F. Yeah, in figure F, I have shown that is the side figure. Flux linkage has been represented. So figure F is representing the flux lines according to the applied field of the magnetic field of saturation that has been placed of the magnetic domain. So this flux field will generate, and the generated field will be measured using the principle of Halsey effect. If you try to recall the figure F, it is working based upon the Halsey effect, or this can be computed based upon the voltage that has been generated in the conductor. So kept in right angle to the flux link. Okay, so the value will be proportional to the input strain or the force. So whatever the change in length that we people are getting, it is totally depend upon the strain or the force that has been exerted. Now, what are the different applications that can be carried out using this particular aspects? Now, there are large number of applications using this magnetostrictive transducer that can be carried out. So as it is bifurcated in two modes, one is your Joule's effect and another one is Worley's effect. So magnetic to mechanical and mechanical to magnetic. So in both the way, you people can use this one for different application. So here your magnetic energy you are converting into mechanical one. This can be used to produce a force. To produce a force. So in actuators, actually, we people are using this Joule's effect. Okay, so magnetic field sensors or starting of a switch uh, using magnetic field that can be also carried out using Joule's effect. If we are using a mechanical energy in the conversion to magnetic field, so this can be used for detecting the force or a motion, which we people are studying now. Actually, if I am interested to measure a force or a motion, at that time we can use the second one, that is mechanical to magnetic energy. When we are applying a force, when we are applying a force, so depending upon the force that has been applied, how much magnetic field or magnetic energy generated, you can calibrate that magnetic energy into your force. So in recent days or previous days also, this device was used for large number of applications. Torque meter, sonar scanner device, hydrophones, telephone receivers. So these can be used. And recent days, with the invent of the GANT, magnetostrictive alloy is being used to make a device like a high force linear motors having a high force, petitioners for the adaptive optic active vibrations or a noise control system. Then medical applications are there. Large number of medical applications are there. For example, pacemaker, if I want to activate or deactivate pacemaker, switch on and off, in that particular medical application, you can use this particular magnetostrictive transducer. And industrial ultrasonic pumps, large number of applications are there. So we will stop over here. So this was the magnetostrictive type of transducer. And in the next lecture, we people will go through the torque measurement. So up till now, we have seen here this can also be used for the force measurement and torque measurement, as I have specified in the detailed description. So in the next lecture,